Scientists working at the Large Hadron Collider, LHC, have identified three strange subatomic particles in their quest to find the building elements of the universe. The LHC's purpose is to enable physicists to verify the predictions of various particles discussed in physics theory, such as measuring the properties of the Higgs boson, hunting for the enormous family of new particles promised by supersymmetric theories, and other outstanding particle physics concerns. Scientists at the Center for European Nuclear Research, CERN, have discovered a new type of pentaquark and the first ever pair of tetraquarks, bringing the total numbers of new hadrons found at the LHC. Let's find out in today's video what scientists find out and how it may affect the universe. The LHC at CERN in Geneva is set to run at a record energy of 13.6 trillion electron volts for nearly 4 years. The modification should improve the precision of LHC equipment, allowing for more particle collisions, brighter light, and more quantum field theory finding. There is a tunnel, and machinery inside that tunnel releases beams of energy into a large circle accelerator, changing the weight of one electron, destroying our universe, and shifting us into the universe just next to it, where things are different. Physicists from all around the world were ecstatic to find the world's most sophisticated high-energy particle. After all, they had patiently waited for decades to eventually witness this incredible discovery transform our knowledge and understanding of the universe. After an extremely long construction period, the European Organization for Nuclear Research's Large Hadron Collider became operational in September 2008. However, it took the machine's developers several years to build the collider. But since then, the Large Hadron Collider has helped scientists unravel many of the universe's mysteries in several runs. However, CERN scientists just stated that when they turned on the Large Hadron Collider with a new maximum energy beam, they noticed something unexpected and alarming since this occurrence, and they've been attempting to figure out what caused it, but all they have discovered so far are hypotheses that may or may not be correct. CERN built the world's largest and most powerful particle collider between 1998 and 2008 in collaboration with over 10,000 scientists from hundreds of colleges and laboratories in over 100 countries. It is erected within a 27-kilometer-long tunnel and located around 175 meters beneath the France-Switzerland border near Geneva. The first collision in this Hadron Collider happened in 2010 at an energy of 3.5 tera-electron volts per beam, about 4 times the previous world record. After renovation, it hit 6.5 tera-electron volts per pulse. The collider has 4 intersecting locations where the speeding particles collide. Each of these 7 detectors is designed to detect a different phenomenon and is placed near the crossing area. The Large Hadron Collider primarily collides proton beams, but it can also accelerate beams of heavy ion, particularly lead collisions, typically undertaken for 1 month each year. Hadrons are subatomic composite particles comprised of quarks bound together by a strong force, similar to how atoms and molecules are held together by electromagnetic energy. Popular known hadrons include baryons, protons, and neutrons. These hadrons include mesons found during cosmic ray research in the late 1940s and early 1950s, such as pion and chaon. What exactly do we mean by a collider? Well, it is a particle accelerator that combines 2 opposing particle beams so that the particles interact. Colliders may be difficult to build, but they are tremendously strong research tools in particle physics because they attain a much higher center of mass energy than fixed target configuration. Scientists can then examine the byproducts from these collisions to learn more about the subatomic world's structure and the rules governing it. Just a few of these byproducts can only be produced by high-energy collision. They break down in very short amounts of time, so there's no other way to study them. The collider is in a circular tunnel 50 to 175 meters underground. This depth difference was made to cut down on the amount of tunnel that lies under the Durham so that a vertical access shaft wouldn't have to be dug. This tunnel was chosen so that CERN wouldn't have to spend a lot of money buying expensive land on the Earth's surface. This would also change the landscape. The tunnel is 3.8 meters wide and was built between 1983 and 1988. It is lined with concrete and used to be the home of the Large Electron Positron Collider. At 4 points, this tunnel goes through both Switzerland and France. The largest side of it is in France, though. In the building above ground, there are compressors, ventilation equipment, control electronics, and refrigeration plants, among other things. The amount of data produced by the LHC and simulations related to it was estimated to be about 15 petabytes per year. The computing grid was built as part of the LHC to deal with these vast amounts of data. It is an international project that includes grid-based computing computer network infrastructure. It cost about 7.5 billion euros to build a section of the Large Hadron Collider. It is one of the most expensive scientific instruments ever built. Its construction was approved in 1995 with a budget of 2.6 billion, and another 210 million went toward experiments after it started working on September 10, 2008. This whopping sum of money will be worth over $2 billion in our modern world. The first set of tests during the first run of the LHC from 2010 to 2013, a problem called magnet quench caused more than 50 superconducting magnets, their mountings, and the vacuum pipe to get a lot of damage. This set the project back to 14 months. Two beams of protons with lead nuclei with up to 4 tera-electron volts of energy hit each other at the LHC. In its first run, the LHC found the Higgs boson and a number of composite parts, such as the botonium state. It also made the first quark gluon plasma. The Large Hadron Collider was first used to investigate whether or not the Higgs boson existed. The Higgs boson is a key part of the standard model of particle physics that was predicted by theory, but hadn't been seen because it has a high mass and is hard to find. After their first tests in 2008, there was a long break for upgrade. The second time it was used was from 2015 to 2018, and then there was another long break until 2022. The LHC started working again in April 2022 with a new maximum beam energy of 6.8 TeV. This round expected to last until 2026, and on July 7th, a crack appeared in the Earth's magnetic field during the third run of the Large Hadron Collider. Scientists are still trying to understand what this means. This mysterious crack didn't happen in a flash of lightning and didn't close up quickly. In fact, the hole in the Earth's magnetic field stayed open for 14 hours, letting the strong solar winds rush through and cause massive geomagnetic storms that made the aurora so beautiful. People who like science fiction were pretty excited to hear this. Some even said that Vecna, the monster villain from Stranger Things, might have crawled out of this crack and into our world. That's just a dream of a true fan, but it will never happen. But the geomagnetic storm caused by this crack did make a beautiful aurora that was hard to look away from. But how did this crack come to be? Well, it turns out that this crack in the magnetic field was caused by a rare event called a co-rotating interaction ring from the sun. The sun is a large plasma structure made when fast, slow-moving solar wind streams interact with the heliosphere's low and middle latitude region. The heliosphere is the area around the sun with the solar magnetic field and the solar wing. Just like the coronal mass ejections, or CME, the sun throws the co-rotating interaction rings toward the Earth. These can have shock waves in tightly packed magnetic fields that make space weather stormy, which we usually see as beautiful auroras. This one hit the Earth's magnet in the early hours of July 7 and caused the G1 class geomagnetic storm that lasted for a long time. Analysts from the National Oceanic and Atmospheric Administration, or NOAA, said a coronal mass ejection was in the solar wind before the co-rotating interaction region. So, should we worry about this crack as well? Obviously, this is nothing to worry about, because these kinds of cracks in the Earth's magnetic field are common. This field acts as a shield to protect us from solar storms from the sun. People believe that the field's many cracks open and close pretty quickly. We hope scientists at CERN conduct proper research on the newly discovered particles and understand how it works so that they will be controlled in case it stands to cause a threat to the universe or probably eject dangerous particles that may endanger lives in our ecosystem. While this happens, the SpaceX Crew Dragon is ready to go to the moon instead of NASA's huge rocket failure. Click on the video to know more about this.